Hello, everybody, and welcome to Hash Rate. My name is Mark Jeffrey, and with me today is Nick White of Celestia. Hello, Nick.
Hi, Mark. Thanks for having me.
My pleasure. So Celestia is a new hyper-scalable blockchain. It's not out yet, so we're expecting it to be released sometime in early 2023. We're here today basically because Can Gurl of Delphi Digital wrote a really excellent report entitled Pay Attention to Celestia. And here on Hashrate, we aim to find new things early and explore them, and as much as possible, explain them simply to people who are just curious about these things. And I'm a student of all these technologies, so I love digging into these and talking to people like you, so I'm really excited to get this conversation rolling. So first of all, who are you people? Tell me a little bit about yourself, and tell me a little bit about Mustafa Al-Basim, your CEO.
Yeah. Well, first of all, I just want to say that I'm glad that that's your approach to this topic, because blockchains in general tend to be obscured by techno jargon, and it's important that we make it more accessible to the average person. And at Celestia, we're doing something that's very cutting edge, and it's hard to explain it in a way that normal people can kind of understand the impact. But we're trying really hard to make that possible. So I think this is going to be a good exercise in that. So my background is I'm originally an electrical engineer, and I got into the AI industry at the beginning of my career before learning about blockchain and really diving deep down the rabbit hole in 2017. And I finally made the jump full time in 2018 when I co-founded a project called Harmony, which was also a blockchain layer one that was aiming to solve scaling. And then I worked on that project for 2.5 years. And in mid 2020, I learned about a new approach to scaling, which was this concept of modular blockchains. And it immediately made sense to me and completely, changed the way that I understood blockchains fundamentally. And I knew that it was going to be a huge paradigm shift in the industry. And to me, it was the biggest leap forward in blockchain architecture since the advent of smart contracts and Ethereum itself. So that's what led me to Celestia, which is the project that kind of coined the term modular blockchain and has really been at the forefront of this new revolution. About Mustafa, he's sort of he's the CEO and co-founder of Celestia Labs, but really the visionary behind the project of Celestia, the protocol network, and also sort of the originator of this idea of modular blockchains. And he is, aside from the fact that he, had this really brilliant idea that we'll discuss, I'm sure later on, he has a very interesting background, which is that he taught himself to code when he was very young, around like age 9, and then started, because his passion just naturally led him to essentially hacking. And so he started hacking by the time he was like 12 years old, and was involved in groups like Anonymous and then also LulzSec later on. And he was very motivated by this idea that you can use computers to sort of transcend the sort of like power dynamics, the structures of power in the world, right? We live in a world where power is concentrated among very few hands. But if you have the necessary skills, using a computer and using the internet, you can actually sort of break free from that and put power in its place and redistribute power to the average person. And so in his hacking career with Anonymous and LulzSec, that was kind of like his goal. And so they hacked different organizations like, various FBI affiliates and the U.S. Senate, multinational companies that were doing bad things. It all, eventually it got shut down.
It's amazing you didn't end up in jail. I mean, it sounds like, sounds like
luckily
tap dancing on the line there a little bit.
Yeah. Well, luckily he was only 16 years old, so couldn't. He just had to like stay off the internet for a couple of years and whatnot. But anyway, I think the through line of his whole sort of like life has been, how do we use computer science and technology as a way to make the world a better place, specifically to like equalize power among people. And I think Celestia and crypto is very much a continuation of that.
Yeah, crypto's definitely got that vibe for sure. Code for social change, if you will. So let's move on now. Let's talk a little bit about what. First of all, great name. I love Celestia. Great name, right? A lot of other, some other blockchains are like Cardano, which is not nearly as majestic and awesome. So right away, you guys win in the marketing department. So let's state the problem of scalability. Right now, life started kind of in this world with Bitcoin, and then really Ethereum was the start of, the current age with programmable blockchains. But as we all know, Ethereum has giant gas fees. It can only do 10 to 21 transactions per second. They keep saying they're going to upgrade it, but, who knows? I've been hearing this for years now. I'm not sure if, they're actually going to get around to actually fixing all these issues anytime soon, despite the claims that we hear. So over the last 2 years, we've seen the rise of the alt blockchains. So things like Solana, things like Binance Smart Chain, EOS to a certain degree, Polygon and Phantom. All these things, basically, DeFi rose over the last couple of years. We saw Ethereum's market share go from 100% to 50% in DeFi, right? And these other alt chains kind of slurped up 50% of the market share. That's a lot of market share to lose in 2 years, right? Especially in a $100 billion industry now. It used to be $200 billion at the peak. It went from sort of 0 to $200 billion. So, Ethereum bled a lot of users. And my overall point here is the Iron Throne of the settlement chain remains vacant. The fight is on. Nobody rightly rules it yet, right? So it's anybody's game to win. Ethereum might win it, but they might be the MySpace. We don't know yet, right? It could go either direction right now. So there are several people who have named Celestia as a possible heir to the throne, even though it's not here yet. The ideas behind it are powerful enough that a lot of big brains are saying, yeah, this could be the one. So So first of all, do you agree with that characterization?
I do. I think one way to think about the last chapter of blockchain evolution, right? So there was Bitcoin that started this whole space, and then Ethereum. The idea for Ethereum came around in 2014, and the network launched a few years later. But and that was kind of, to me, those are the two major steps in the evolution of blockchain technology. And all of the projects, these alt layer ones that have come after Ethereum, have kind of just been taking the same theme, the same idea, and iterating on it or optimizing it. But they're fundamentally not actually doing something very different. And so I think, did you raise your hand?
Yeah. I was just going to jump in there because I think you're touching on the idea of modular blockchains. So let me just I'm going to try to frame this again. Here we try to do the simple speak as much as we can. So the other blockchains, the Solanas, the Phantoms, basically all of those blockchains are what is called in the industry monolithic. And all that means is that it's one big honking computer, right? So, and it's shared between all these people who are on the blockchain, but it's like all of us are logged into one computer. And there are things you can do to make that one big honking computer better. You can add more memory. You can add more CPU. You can upgrade the CPU. Like, Polygon just yesterday announced this new ZK VM. That's effectively upgrading the CPU of the Polygon network blockchain. And Phantom has something called the FVM, Phantom Virtual Machine, which is sometime in the future, but that's their bid to upgrade their monolithic blockchain. You guys are not upgrading the big honking computer in the sky. You have a fundamentally different approach where you break up all the pieces and the functions of what that big honking computer does, and you basically make it something sort of like Amazon Cloud, sort of like BitTorrent, in that the more users you get, it just infinitely scales to accommodate those users, and you never run into the eventual bottleneck of centralization that these other blockchains run into. Correct or not?
Exactly. That was a really good summary. So the way to think about it is as I said, all these, since Bitcoin and Ethereum and all these other ones have all followed the same design paradigm, which is a monolithic blockchain. And when your blockchain architecture starts from that design paradigm, you are stuck within some certain fundamental constraints of scalability and some others that we can get into later, but scalability being a really big one, right? Because that's one of the biggest problems facing the space. And the only way to break through that is actually to take this modular approach. Now, a good metaphor to understand this is sort of like, you can think of a monolithic blockchain as sort of like a mainframe computer, where it's a big computer and it is sort of like already built out and it has a certain amount of capacity. You can't just add more resources to it. It has a finite space. And you can think of all these applications and users all trying to share one computer. And in the same way that, when your laptop has too many apps running on it at the same time, it starts to slow down and it might even crash. That is what's happening.
We've seen Solana crash multiple times over the course of this year because during an NFT mint, they have bots trying to grab the NFT, and basically it just, it DDoSs Solana out of existence and it goes down. And they have to, it's down for 8 hours and have to reboot it. So what you just described, it happens in real life on real world chains.
Exactly. So you can kind of picture that happening with these monolithic blockchains, right? They're getting overwhelmed and they only have a finite capacity that they can't expand. Now, what a modular blockchain does is a lot more, like you mentioned, AWS or cloud computing, where a cloud computer it basically runs on a data center, right? And a data center is this highly scalable, highly cost-effective, and also, importantly, extensible resource. Like you can continuously, it's not a mainframe where it's already built and that's it. You can actually connect more computers to it, more servers, to give it more capacity. And also on a cloud computer, people, it's not like, Instagram and Snapchat and, all these different web apps are running on the same shared computer. The applications are actually split out into their own separate sort of like infrastructure. They might be running on the same, co-located on the same data center, but they're actually not competing for resources. So that's why the apps can be more reliable and more scalable. And so in Celestia, it's the same way, where we provide this data center resource for people to run their blockchain applications, but they can actually sort of like keep their infrastructure separate in the ways that do matter. So it is like we're taking blockchain infrastructure from sort of mainframe to cloud level of architecture.
Yeah, so I'll so one quick story from my side. So a lot of people don't know this. I used to work for Travis Kalanick, who later became the CEO of Uber, back when he was at Red Swoosh. And Red Swoosh was a file delivery network, and it was based on his experience with his previous company, Scour, which was basically a Napster clone. And what they noticed was a really interesting phenomenon where, in the old way of serving files, if you were trying to serve a movie up and that movie was popular and you were serving it out of a centralized server, at Paramount or whatever, the more demand there was for that movie, the more that server would tend to get overwhelmed and collapse, right? Whereas in a peer-to-peer network, every time, if there was great demand for a movie, everyone who downloaded that movie was now a server of that movie. So basically the serving capacity became exponentially larger the more popular a file got, right? So the network operated correctly. Its strength increased with demand. It didn't decrease with demand, right? So, which is, I think, sort of the effect you guys are trying to get with the architecture of Celestia, right? That's basically what BitTorrent and other things do, right?
Yeah, exactly. So one of the properties that Celestia has that monolithic blockchains don't have is that the more nodes there are on the network, the more capacity the network has. So, and that's the distinction, right? In Ethereum, or Bitcoin, no matter how many people are running full nodes on the network, the capacity doesn't change. So, and that's why, for example,
let me stop you right there, because this is
okay.
where we start losing people. So let me just try to let's talk about this for a second. I think this is really important.
Yeah.
So the full nodes are exactly what it sounds like. They are processing transactions. They are ordering the transactions. They are executing virtual machine code. And I know I'm lying a little bit because I know those functions are actually separated in Celestia, but just for right now. So, the full nodes in most networks do that. The light nodes, they're basically read-only. They're not writing transactions. They're there for other applications, sort of like RPC servers in Ethereum, where if you want to see if a transaction occurred, you can query a light node and see if it's there. Is that basically correct, or am I missing something?
Sort of. I think so. We can go deep into this concept, but I think the important thing for people to know about what is the difference between Web 2 and Web 3, between like a normal, just like internet application and a blockchain application, is that blockchains are verifiable by end users. The whole point of a blockchain is that we can build these systems that you don't have to trust someone else to know that the rules are being followed, that no one's cheating you, right? And so what a full node in a blockchain, there are people who are operating the network, who are running it, who are actually, building the blocks and executing the applications. And those are the miners and the validators. And then there are the full nodes and in our case, light nodes. And a full node is actually not, the point of them is not actually to run the blockchain, but rather to verify that everything is happening as expected. So if you want to be trust minimized and not have to worry about someone cheating you, you run a full node. And so one of the key differences in Celestia versus a monolithic blockchain is that we have this new type of node called a light node, where it requires, like an average full node is very expensive to run. So for example, on Ethereum, you need to dedicate an entire laptop, actually probably more.
Solana, it's like
to run it.
The requirements are absolutely insane, famously, right? To run.
Solana is totally insane. It's very expensive and also probably requires like too much technical savvy as well. And the beautiful thing about modular blockchains and Celestia is that you're actually able to run a node on your phone. So the amount of resources required is dramatically lower because of the properties of modular blockchains. So you can run a node on your phone and not have to trust anyone else that everything is happening. I think that's a very powerful thing, because that enables anyone with a mobile phone to be a first-class citizen of the Celestia network. And that's really what blockchains are meant to be. They're meant to empower people to take, control and to be empowered and know that they don't have to worry about someone else who they have to trust, if that makes sense.
So if I run a node on my smartphone, Celestia node, do I get rewards for running that node? I assume I get something for that, right?
So as of right now, we don't. The issue is that it's very easy to Sybil, meaning that you can run a lot of these nodes and then basically not actually be contributing to the network. So it's very hard to prove that you're actually contributing when you're a light node. However, the benefit is that, again, you are a first-class citizen. So I think there's an incentive if a lot of your livelihood, and in the future I think this will be the case, a lot of your livelihood will be on blockchains, that you will want to know that everything is functioning as it's meant to be and that you're not being cheated, essentially.
Got it. Okay, so it's sort of like running an RPC. It's like running your own RPC server in Ethereum, somewhat analogous to that. It's not exactly analogous, but that's how I think of it. Your face is telling me I'm totally wrong. So what am I getting wrong?
Yeah, it's more about, so blockchains are inherently like political, like they are social coordination tools, and an important part of the social benefit is that they are trust minimized. So the reason, like you run an RPC node, I guess, to have the ability to query the blockchain and post things there and sort of interface with it. In this case, the light node is it does enable you to interface with the blockchain, but it's mainly about verification.
You're sure? So in other words, RPC nodes can be fooled. That might be bullshit, right? Whereas your light node, you're interfacing directly.
No, our RPC node is also a full node, but it's mostly just, it's meant to serve as sort of like an interface an endpoint for developers and people to interact with the blockchain. Not so much, yeah. So anyway, I think we can.
Okay.
It's a small enough distinction that doesn't matter that much.
No worries. I did want to talk about one thing that I found fairly interesting in Kangirl's paper. The magic by which you accomplish this these light nodes is through something called erasure coding. And Can did not explain exactly what that was, but my understanding, based on what he wrote, was that basically there's a way to make it so that the light nodes only download the block headers, and the block headers are encoded with this erasure coding, and that gives the light nodes the ability to make random queries to make sure that the information in the block headers are accurate. In other words, all the transactions are included, and everything is supposed to be there is, and nothing has been messed with. And basically, the light nodes all kind of gang up to spot check whether the information in the block headers are correct. So it's sort of like they all do a different test, but collectively they kind of test everything. Is that correct?
Yes. So in Celestia, one of the main problems we solve is this thing called data availability. And it's very different than like data storage. It's basically unique to blockchains, where you need to, in order for these systems to be, trust minimized and secure, you have to make sure that the data behind the chain, all the transactions and all the activity that's going on, has actually been shared publicly to the entire network. And basically, one of the issues is that usually to verify that, you would have to download all that data yourself. But clearly, if I'm trying to run a node on my smartphone, I don't have the bandwidth or the storage to download all of that information, especially if we want these blockchains to really scale and have lots and lots of data being processed and lots of transactions. So the solution is that there's this ingenious mechanism that Mustafa and Vitalik designed together in a paper in 2018, where you take the normal data and you apply erasure coding to it. And erasure coding is basically a way to add redundancy. So, for example, in a CD-ROM, how do you make sure that when the MP3, when it gets scratched, that you don't lose the file? And the answer is they add extra data that allows you to recover the original data. So if you lose some of it, you don't lose all of it, if that makes sense. Yeah. So in Celestia, we do a similar thing with the block data itself. So we add redundancy to it. And now, if let's say the person who is producing that block decided to not actually share all the data, like some of the data is gone and missing, you would be able to detect it very easily, because even if they wanted to withhold a very small portion of it, they would have to withhold over, let's say, 50% of it in order to withhold any of it, if that makes sense, because of the natures of erasure coding. So that way, you can just sample a bunch of it. You can download maybe 1% of the total data, and each time you take a little chunk, you check a little piece, you can you have a higher confidence that all of it is there, if that makes sense. Because it's kind of like flipping a coin. You flip a coin, 16 times, and every time it's heads, then you have a very high degree of confidence that the overall thing is secure and all the data is there.
So it's sort of like making data holographic, where if you snap a hologram in two, right, each piece contains the whole thing, just at a lower resolution. But you haven't lost the whole thing when you lose half of a hologram, right? So when I read the erasure code, I was like, that's really interesting. It feels very holographic. So yeah. It's super cool, super cool. So now, with the idea of a modular blockchain, let's go back to that for a second. So you take the functions of a blockchain and you subdivide them up. So one example of this is you have one piece of the computational power of the network ordering transactions, but making no judgment whatsoever on the validity of the transactions. So just what order did we see these in, and determining that, and that's all it does. And then there's another piece of the computational power which actually does make a decision on whether the transactions are valid and executes the transactions if they are, right? So I think there's like 8 or so different sort of subdivisions like this. Is that correct?
There are about four subdivisions. And so the key point is that in a monolithic blockchain, the same protocol and the same set of nodes all do all the work at once. And when you do that, that's where you get those constraints. In Celestia and in modular blockchains, the insight is that actually all those things don't have to happen at the same time in the same protocol by the same nodes. And we can actually separate them into separate functions and design protocols that specialize in each function. So, for example, those 4 layers are, we don't have to go super deep into them, but number 1 is consensus, which people who have been in blockchains for some time have a sense of what that is. It is essentially the ordering of data. You need to have everyone has to agree on the view of the history of events. Then there's
because if I spend $1, right, and now I've got nothing, I can't give another dollar to you. So the ordering the transactions to make sure I don't spend the same dollar twice is super, super important in blockchains. And in fact, is one of the key problems that Satoshi solved. So for those of you who don't know.
Yes, exactly. Very, very good point. The second one is data availability, which is what we talked about. It's basically knowing that all the data is transparent and everyone can see it. Because if people can't just see what's happening, then it's not you can't actually trust what's there, essentially. Then there's execution, which is where the applications and smart contracts and all the use cases live. So that's where that's the computation part. And then last but not least is this thing called settlement, which is basically a way for people to resolve disputes. So between different execution formats, you need to have like this way of resolving which transactions are valid and invalid. It's a more in-depth, I guess, conversation to explain settlement.
Sure. Okay, so the question I have about, so we all understand the same thing there. The question I have about what you just said is you have these 4 subdivisions. Aren't those 4 subdivisions monolithic within themselves? So in other words, each one of those 4 things does not scale infinitely. They ultimately run up against the hard limit of centralization the way the monolithic blockchains do. Of course, you get vastly greater capacity, but there is still a limit. Or is there something I'm missing?
So for each one of them, so there's a few different things. One is that by separating these out, we can design a protocol that actually is, orders of magnitude more scalable. And so, for example, in solving data availability, that's kind of what Celestia has done. By separating out data availability and solving that, and not doing any execution or any other kind of thing on that protocol, you can make
data availability being the light. Sorry, I just want to make sure I understand. Data availability basically being the light nodes, and the fact that there's a zillion of those. That I buy. I buy completely.
Yeah. So Celestia, just to give an example, is a protocol where we purposely do no execution. So there are no applications. There's no smart contracts. So it sounds like it's really not useful. All it is a blockchain. It just provides raw block space, but that block space is very secure and very scalable. And the reason we can do that is because when you remove execution, you can change the way that the protocol works in a way where that data availability sampling thing is possible. You can't just do that on a blockchain that also has execution and all these other things combined with it. So and that's why the original paper and the original name of the project was Lazy Ledger, because the idea was that we were building this ledger that's lazy, and counterintuitively, by doing less, by not doing execution, by just focusing on very simple stuff, we get all these benefits of scalability and several other things. So that's a core concept. I think laziness is actually a core concept for modular blockchain. It's like, don't try to do everything at once. Just be lazy, focus on your one thing, do it really well, and then everyone's better off, essentially.
Yeah, another word for lazy would be focus. In this, right?
Yeah.
Yeah. So which I completely agree with. So okay, so what I just said was wrong. It's not because of the light nodes that provides the massive data availability. It's the subdividing of the functions, and in fact, not doing, executing code and virtual machine stuff. That is what provides the the massive data availability. Correct? Okay. So
Yes.
this is how we learn. I have to be stupid in public. Otherwise, I don't ask the questions and nobody learns because everybody's thinking the same question, right, or similar questions. So this is how we learn. No ding on anybody. So okay, so if there's no virtual machine, so basically Celestia provides this overarching blockchain infrastructure. If I want to write smart contracts, I have to create another blockchain, which is sort of like a subchain inside of the Celestia universe. Is that correct?
Exactly. So one of the ways I like to explain this to people, and it might, forgive me because it takes a little bit of some technical knowledge, but expanding on the cloud computing analogy. So one of the, enabling things of cloud computing was this concept of virtualization, right? You have VMware, who were the first people to virtualize x86 sort of like architecture, and that enabled all this stuff. So so what a cloud computer is like you have that data center, and then people are like tapping into the computers there to run their computers on top of that computer. So it's kind of like a computer within a computer.
You have a computer made of software. It's like being on the holodeck, but on the holodeck there's a computer, and that computer is made of just holodeck computation. But it is in fact a complete copy of a physical computer. It's like that. Yeah,
exactly. Hopefully that we didn't lose people, but so computer within a computer is sort of what enables the cloud. And in a modular blockchain, what enables this, or one of the key technologies, is running a blockchain within a blockchain, and that is what a rollup is. So a rollup is another very popular term within blockchain circles, and it's essentially this way of running the execution part of a blockchain, but borrowing the consensus and data availability of another blockchain. So you can kind of think of Celestia. Celestia is a blockchain, and its blocks within the Celestia blocks are blocks of these rollups embedded in it. So the rollups are blockchains that run on Celestia as like this.
It's Inception.
Sort of
it's blockchain Inception. Yes.
Exactly. So that's kind of a very key point, is that you have a blockchain within a blockchain.
Okay, so for my blockchain, so I want to create like Mark's chain, right? And
yes.
So now when I create my blockchain within your blockchain, I assume I have to supply my own validators on my end to run my blockchain within your blockchain. Is that correct?
So this is a very good question. So again, on this sort of like web analogy, like if you think about Amazon EC2, Elastic Cloud Compute, the power of it is that I, as a developer, can go to Amazon and say, hey, I want to deploy, this virtual machine with this operating system and whatever snapshot, blah, 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 right? It's all configurable and like on demand and just a few lines of code and it's there. I don't have to worry about the infrastructure piece. And I just pay as I go, I don't know, $1 an hour or however much, depending on the amount of computation that I consume. And Celestia is a very similar model where, again, instead of the data center, we have that provides raw compute. We have a blockchain that provides raw block space. And as a developer, I come to it and I say, hey, you know what? I want to run the EVM, and I want to have start it with this initial state and blah blah blah, and boom, I want to spin it up. And Celestia essentially handles all the infrastructure part of it, and you pay as you go, for however much block space you consume, if that makes sense.
It does.
So you don't need to have your own validator set. That is one of the key parts of it. It makes it way easier.
That's pretty cool.
Yeah, it makes it a lot easier to deploy your own blockchain. So one of our goals is to make it as easy to deploy a blockchain as it is to deploy, a web app on AWS or a smart contract on Ethereum.
So like in the Matrix when they say, I need guns, lots of guns, it's just whoosh, the guns appear, right? A ton of them on either side. You're like, I need blockchain servers, lots of them. and Celestia just makes them appear like that, right? So yeah, that's super cool. Okay, and I don't have to provide my own validators. I can specify like what EVM I want to use, or what VM I want to use.
Yeah, so that's the other beauty of like, so in a monolithic blockchain, right, on that mainframe computer, it comes preloaded with an operating system, right? And you can only run applications that are, I guess, compatible with that operating system. So in Celestia, it doesn't have an operating system preloaded in it. You come to it, and when you deploy your blockchain, you say, hey, I want to use EVM, or I want to use Solana's C-level VM, or I want to use WASM or Move, or all these new VMs that people are still creating. And frankly, it's still so early in the blockchain VM development space that it's way too early to lock into any one particular execution environment. So, and also the experimentation of execution environments has been held back, because imagine if every time you wanted to test out a new execution environment for a blockchain, you had to literally build an entirely new blockchain. So Celestia changes that. It makes it so you can just, roll it out, dream it, and then, click a button and make it happen.
Got it. That is super interesting. So Celestia's not really another blockchain. It's more like an Amazon Web Services for blockchains, right?
Exactly.
That's kind of more like, so it doesn't. Yeah, it's actually a different beast that supersets all the other beasts in a weird way.
Exactly. Yes.
Yeah. Okay. All right. Starting to get it now. I'm starting to become less stupid. This is why we do these things, right? So, okay. So let's move on now. So you're planning on releasing it in 2023. Is that correct? Like early 2023?
Yes.
Or is that sort of up in the air?
Yes. So we will launch our mainnet in the first half of 2023.
Okay. And there will be a token, a Celestia token of some sort?
Yes, absolutely. So all of these things, the things that Celestia does require a token. So first of all, we need a token to power our proof of stake protocol, because that's sort of the Sybil resistant mechanism and sort of what powers the consensus portion of our protocol. We also need the token as a way for people to pay for fees on the network. So when you when you come to AWS, you pay per compute cycle that you consume. In Celestia, you have to pay for that block space. And just like in Ethereum, where you pay for gas on the Ethereum computer using ETH, you will pay for using Celestia block space in our native token. So that's the main function of the token.
Got it. That makes total sense. And now all these other ecosystems, and now we've established you're actually kind of a different beast. But all these other ecosystems, you're sort of competing with them anyway on some level. Near has an $850 million war chest. Phantom and AVAX both have like a $500 million war chest. I know Solana's got, I don't know what they've got, but they've got a war chest also. All for, basically investing in apps in their ecosystem. Will you guys also come to the market with something like that, or is that not how you're going to play the game?
I think we absolutely need to help, I guess, bring about an ecosystem, like breathe life into an ecosystem. There are a lot of ways of doing this. One of the beautiful things about Celestia is that we can benefit from all of the other tooling that other blockchains have built or other ecosystems have built. For example, when with the EVM, with all the tooling and great developer adoption that is there, I think developers, I guess what I'm trying to say is, are more loyal to a particular VM environment that they're used to, rather than actually a particular L1. Like the layer one, the blockchain behind it is sort of just like, where are you pointing your RPC at? Where are you pointing your node at? Right? Like, what is the network configuration? Whereas for the developer, it's actually more important. Like, well, what IDE am I used? What languages am I used to building in, and all of that. So I think that is the beautiful thing about being agnostic to all these different virtual machines, is that we can support all of them and kind of onboard any ecosystem of developers can be kind of onboarded to Celestia. That said, there is an element of ecosystem development where we want to have, applications and liquidity and certain key features that I think will help incentivize more people to build on top of Celestia, for sure. And so we will be pursuing those kinds of things.
Got it. Okay, so announcements to be forthcoming sometime in the future. So, so I think that's kind of all. Those are all the questions I have. Is there anything that I should have asked you, or that you want to add to what we've discussed here today?
I think we covered a lot of stuff. The last piece that I think is also really important for to understand why modular blockchains are so revolutionary is this thing called interoperability. So people who are into blockchains will know about this problem of like each blockchain kind of lives on its own world, and but we want them to be able to connect and talk to each other. And so people have been working on this problem, and now we have bridges all over the place.
Yeah, bridges for the like very specifically to move to a token from Ethereum to Phantom, from Phantom to Binance Smart Chain. Those are bridges, so your tokens can actually jump chains. Or if you have oracles, if you want to determine the price of something on another chain, you need that communication between the chains also. So that's specifically why you want communication between chains. Please continue.
Exactly. And so you can see why this is a really important thing. It's kind of like, in the internet, imagine if people were building websites, but those websites couldn't hyperlink to each other. They were just, standalone static, and you could go to, one, and you could go to YouTube and just, do YouTube, but you couldn't then transfer that over to Google or Instagram or what have you. And so this is a really important thing that we need to solve. And a lot of smart people have been building the technology that is going to get us there. But the problem is that bridges are inherently, in the wild, are inherently not very secure, because there's a lot of different reasons. One is
so
by
many
design.
hacks.
Like some people.
Yeah. The Ronin hack for 700 million was a big wake up call. So this is a real thing.
And it hits close to home for me as well, because as a co-founder of Harmony, a few months ago, Harmony was also hacked. And so this insecurity is due to a few different things. In the short term, it's because people have been taking shortcuts and doing multi-sigs and stuff like that, and that's just bad practice. And I don't see that as that's a problem that's different to the problem that modular blockchain solves. But even if you try to make that as sort of trust minimized as possible between chains, you end up in the situation where still that bridge is not very secure, and every time you're creating that connection, that hyperlink, it's as if that other website, that other chain, if it became malicious, could basically steal money from your chain. So this did happen actually with Terra, when the price of Terra or Luna collapsed, it essentially became very cheap to corrupt the Terra chain. And Terra had a bunch of bridges with a bunch of other chains, like Osmosis, for example, and they could have stolen like tens of millions, if not hundreds of millions of dollars from Osmosis. And so we're basically living in a world where we're building these hyperlinks, but they're based in HTTP, where before HTTPS, someone could have just like eavesdropped and stolen information from you. But in the blockchain context, we're in HTTP, where these different chains can actually steal funds from each other. So it's actually, arguably a lot worse. And this is where the modular blockchains come in, is that if roll-ups that are built on a shared data availability layer like Celestia can actually have a new type of bridge, a new type of hyperlink that is ultra secure, like as secure as it can get theoretically. And so it's like an upgrade from HTTP to HTTPS for blockchain interoperability. So we can actually have all these websites and all these separate apps and chains and computers talking to each other. So it's a real internet of blockchains, which has been a dream of blockchain people for years now.
Thank you. That was so. Just overall, dude, thank you so much for this interview. Really, really interesting, and thank you for putting up with my stupid questions and slow understanding, but then finally getting it on a couple of these things. But it is a complex topic, and it's a really important topic to try to. And it's hard to explain this stuff in a simple way. So thank you for coming on and doing that. I learned a lot personally in this interview, so Super fascinating. I will absolutely be watching, and I'm a fan. So thank you for your time.
Mark, it's my pleasure, and hopefully this made sense to people. I remember when I was learning about it, it took me a long time to wrap my head around it, and so there's no shame in asking questions, and you can always ask us questions on Twitter. We have a lot of resources on our website, celestia.org, and some videos, a lot of other interviews that people can watch if they're interested, and we'd love to hear from people and get involved in our community.
Okay. Well, that's all the time we have. Thank you, Nick. This has been Hash Rate. We'll see you next time. And Nick, stay